Understand subintervals in linear and quadratic functions. First, let's talk about interval notation and subintervals. The interval 1, 7 with brackets means all values between and including 1 and 7. Remember that the brackets mean included. If we divide this interval into 3 subintervals of equal length, what is the width of each subinterval? That is something to keep in mind, is that all subintervals must be equal length. So if I get a number line and have 1 to 7 with brackets divided into 3 subintervals of equal length, you can see we have intervals from 1 to 3, 3 to 5, and 5 to 7. Therefore, the width of each subinterval is 2. That's easy to do if we have small numbers, but sometimes we're going to have larger numbers to deal with, and therefore a subinterval formula will be easier to work with. The subinterval formula is delta x equals x sub 2 minus x sub 1 all over n, when the interval x sub 1, x sub 2 is divided into n subintervals of width delta x. Let's do an example. Let's divide the interval 517 into 4 subintervals. And remember, the subintervals must be of equal width. We're going to substitute into our formula. Delta x equals x sub 2 minus x sub 1. So 17 minus 5 all over n, which is 4. Our numerator simplifies. 17 minus 5 is 12. 12 divided by 4 is 3. Therefore, the width of each subinterval is 3. Now, let's go ahead and find each endpoint. If we have 4 subintervals, we will have 5 endpoints, because we have one at the beginning and at the end, and then of course the endpoints in the middle that create the subintervals. To do this, we will start with what we are given, and we are given 5 as our first number. Because the width of each subinterval is 3, we take 5 plus 3 to get 8, and the next endpoint is 8. If we continue to add 3, because that is the width of each subinterval, you will see the 5 endpoints are 5, 8, 11, 14, and 17. Notice the first and last endpoints are the endpoints of our interval. Let's go ahead and talk about functions. Let x sub I be any x value. Then the corresponding y value can be calculated by finding f of x sub I equals f of x sub 1 plus I times delta x. Let's do an example. Given the function f of x equals 3x minus 1 over the interval 8, 29, divided into 3 subintervals. The width of each subinterval is 7. Find f of x sub I. You'll notice that if we have the interval 8, 29 divided into 3 subintervals, that's how we get the width of each subinterval to be 7. With our formula, we are going to take the formula given and substitute in for x. So we will have f of x sub I equals 3 times x sub 1 plus I times delta x minus 1. So the coefficient of 3 at the beginning and the minus 1 at the end come from our given function. Now let's substitute in what we know. Our interval begins at 8, so x sub 1 is 8. And delta x is the width of each subinterval, which is 7. So we have 3 times the quantity 8 plus I times 7 minus 1. We then distribute, have 24 plus I times 21 minus 1. Combining like terms gives us our function of f of x sub I to be 23 plus I times 21.